Welcome back, ARU students. We've made it to Module 5 here. We're going to talk about engine cooling systems and heating, ventilation, and cooling, HVAC systems. So next time you're riding in your vehicle, we got to keep that engine cold. We got to keep that engine from overheating, but I want you to pay attention when it's a really hot day or a really cold day and you're cranking that AC or cranking that heat to make yourself comfortable. Think how much we take that stuff for granted. So it's pretty neat how the system works. We're going to take a look and explain that to you. And again, stuff people take for granted until it quits working, then they freak out. It's cold, I need my heat, or it's hot, I need my AC. So we're going to talk about the components of the engine cooling system, how to bleed the system, and then we are going to fully dissect the HVAC, heating, ventilation, and cooling system. So let's dive right in and start talking about engine cooling. We got some warnings to go over right away here. It's easy to get caught up and not pay attention to what you're doing and burn yourself because engines run, a typical engine can run 180, 190 degrees, and that's going to burn you pretty good. So never open a hot cooling system unless being extremely careful. What that means is opening a cooling system like taking the radiator off. If you just grab a radiator and twist it open on a hot engine, you're going to create probably a 5-foot geyser of coolant in the air, and it's going to be hot enough that it'll burn you pretty seriously. So you can open it hot, but you have to be very, very careful. What I like to do is before opening any cooling system, I like to grab a radiator hose to see if their system is under pressure. So you grab the hose and squeeze it. If it feels like it's rock hard, guess what? There's pressure in there. You need to open that system very carefully. If it squeezes easy, there's no pressure. Don't worry about it. Just open the radiator cap how you normally would. One thing we use is a 3-finger method to remove radiator caps. It's something to just get in the habit of, because if there is pressure in there, imagine you put one finger in the center of the radiator cap and the other 2 you use to twist it off. So that way, if there is pressure in there, instead of that cap being blown out of your hands, you're going to have an extra finger in there to hold it down. So, antifreeze, engine coolant. Let's look at what this antifreeze actually does. Obviously, it keeps the coolant from freezing, given the antifreeze name, but it does a lot more than that. It lubricates all the moving parts of the cooling system, which is basically the water pump. But it does lubricate the system. Different manufacturers use different color coolants. That's something I wanted to talk about. So green coolant is, believe it or not, that used to be in all the vehicles, and now you hardly see green coolant anymore. I think some manufacturers, maybe Subaru, I don't know, some manufacturers still use green coolant, but GM turned to orange. They use orange coolant now. I think it's Honda. Some of the Honda vehicles use purple coolant now. So different manufacturers use different color coolants. I usually use a universal pre-diluted 50-50 mix. I get it in bulk, but it's a universal coolant. It's yellow, and you can put it with any coolant. It mixes with green. It mixes with orange. One thing to be careful of is you're not supposed to mix it was a big thing when everybody went away from green coolant, all the manufacturers, and started putting different coolants in. It's not a good idea to mix the green coolant with the orange or with any of the others, because it can cause problems, cause the system to gel up a little bit, that type of thing. So supposedly, if you're working on a brand new vehicle, I might double check a little bit. I think Ford came out with a new coolant, and supposedly nobody really knows yet if the universal coolant mixes well with that. So I went to a class and they just said, you know what, we don't really know. So to be safe, let's just put the OE coolant in. So, it's kind of one of those things. It'll probably be fine, but if you're working on a brand new vehicle and you're worried about it, maybe just get the OE coolant, and then you'll never have a problem. Let's look at a coolant system. Let's follow the flow here. So we're going to start off at the engine. Let me turn my laser pointer on here. Okay, we're started off on the engine. The red hoses indicate hot. So hot coolant comes out of the engine, of course getting pumped out by the water pump, goes through the thermostat here. The thermostat controls the temp. We're going to talk about that, but the thermostat, when the thermostat opens, the coolant's now going to go through the radiator. So we got hot coolant going into the radiator. You're driving down the road and your fan's right here also spinning in an idle. So you're always drawing air through that radiator. Radiator cools the fluid. It comes out of there and it goes back to the engine. These little hoses here that we didn't talk about are actually going to your heater core. So we're going to explain that a little bit better. Let's talk about these different components. Radiator. The radiator sits way up in the front of the vehicle. It uses airflow to cool the liquid passing through it. So it's basically a heat exchanger. Another thing to know about radiators, it may or may not house an oil cooler and or a transmission cooler. So on this particular one, there's some fittings here and some fittings here. So it's a pretty common practice for transmission coolers to go through the radiator, and it doesn't, of course the fluids don't mix, but the two, it's a heat exchanger, so they exchange heat. So a radiator actually helps warm up transmission fluid when it's cold, because the radiator, the coolant is going to warm up faster than the transmission fluid, and the radiator actually helps keep the transmission fluid cool when the transmission's running very, very hot. So it helps keep the transmission from overheating. Radiator caps and reservoir caps. The radiator cap is where you typically fill the system. Another thing the radiator cap does is it controls the amount of pressure that can be built up in a cooling system. So why is there pressure in the cooling system? It's normal to have pressure in your cooling system, but why is that? Because this is kind of a cool thing. Putting pressure in the cooling system actually raises the boiling point. So by doing that, we raise the boiling point, because when the water starts to boil, obviously that's not good, and that would cause it to overheat. So why is there pressure in the cooling system? Pressure is developed by the liquid expanding as it heats up. So the engine's heating up, the liquid expands, and it creates pressure. Some vehicles use a coolant reservoir and a reservoir cap, like you can see right here. And so instead of a radiator right here having a cap on it, you have a reservoir with a cap on it. These two caps basically do the same thing. They both control pressure. They do the same thing. Radiator hoses, there's always going to be an upper and lower hose. And a little tech tip for you is you're always going to see these little spring clamps attaching the hoses to the radiator, to the water pump, to whatever. That's how they come from factory. I always replace these spring clamps with hose clamps when I have them off. I have such horrible luck with these things that every time I take them off, I instantly throw them away. Because you take them off, you do whatever you got to do, you put it back on, put the spring clamp back on, and probably 75% of the time I've had them leak. So a practice I've gotten into, throw these things away, grab a hose clamp, and put it on there, and you're done with it, and you don't have to worry about it. Thermostat. Thermostat's job is to control the temperature of the engine. It's usually located on the upper radiator hose, or where the upper radiator hose attaches to the engine is typically the thermostat housing. Not always, sometimes it's off the lower hose. But this is considered a wearable part. Eventually it'll go bad. And the reason for that is there's a lot of copper or brass, there's pieces moving in there. As it heats up and expands, that opens and closes, they wear out and they get sticky. So eventually it's going to wear out and go bad. A tech tip, if your engine has been overheated, so somebody's bringing it in for overheating condition, maybe they ran it out of coolant, doesn't necessarily have to be due to a bad thermostat, replace your thermostat anyway, because when it's overheated, that spring's going to get weakened, and we've seen it 100 times. If we don't do it, guess what? It's going to come back overheating because you didn't replace that thermostat. So just do it. Another little tech tip is the spring always faces the heat. So a lot of times, here's an example of a thermostat housing and a thermostat that's open versus closed. But if you're not sure which direction that thermostat was installed, you're like, oh, how did that go? Was that facing up? Was that facing down? Always remember, the spring faces the heat. So the spring in this case, faces the engine. So that's just something, a rule of thumb. Oops. And I wanted to show you this. Here's an example of a closed thermostat versus an open thermostat. So right here, you can see coolant flow. It's kind of bypassing. It's not going through the thermostat. It's going right in and right out. On this one, the thermostat's open, so this is a hot engine. It's going through the thermostat now and coming out this, which is attached to the radiator hose. So on a cold engine, the thermostat's closed, and the reason for that is it helps the engine warm up faster. Otherwise, it'd take all day for the engine to come up to temp. And so the engine coolant cycles within the engine until it gets to a certain temperature. Now that spring starts to open. And when that happens, the coolant rushes out, goes through the radiator, and now begins to cool the engine coolant. Water pump. So the water pump is what circulates the coolant through the engine and through the cooling system, usually driven off the serpentine belt or the timing belt. And here's something you probably didn't know. The weep hole indicates if the water pump is failing. How that works is there's a little hole. Here's a picture one right here. If you see coolant coming out of that hole, that's an indication that you need to replace that water pump soon. And it seems kind of strange, but how that works is if you would cut this open, you would see that there's a seal here and there's a seal here, but that's typically a dry cavity. So the metal impeller that we can't see on the inside of this has a seal, has a bearing and a seal. If water or coolant gets past that point, they put a little hole here so that we can see it. If it gets past that point, it means that seal is failing or that bearing is starting to fail. Either way, you need to replace your water pump. Okay, we're going to skip ahead just a little bit here and talk about the heater core, because this is still part of the engine cooling system because we have engine coolant running through this piece right here. So this piece, the heater core, is located in the HVAC box. And let me back up just a bit here. Coolant is circulating through this piece all the time. When the heat is turned on inside the vehicle, it forces air past the heater core and through the vents in the cabin. So when you turn on the heat in your vehicle, it pushes air past this, and this is going to be really hot because engine coolant's running through it. So in turn, creates heat to come out your vents. The heater core is typically located under the dash, usually in the passenger side, in the HVAC box, which we're going to talk about. There's always two hoses on it, inlet and outlet. Heater cores can become restricted. And how we know when they're restricted is if you have a customer that comes in with a poor heat condition, they say my heat's not as warm as it used to be. The reason or the way to find that is we're going to look at these rubber hoses that come off of here. They're going to be under the hood. Find the heater core hoses and measure them with a temp gun. If you have one hose that's 150 degrees and another hose that's 70 degrees, we know we got a problem. They should be within about 30 degrees of each other. If they're not, you got a restriction in here, and then we need to flush that heater core. But anyway, we're going to talk, before we jump into the HVAC system any further, we're going to talk about bleeding the engine coolant system. So bleeding the system refers to getting all of the air out of the system. The conventional way of bleeding the cooling system is to fill the coolant to the top, allowing the engine to get hot, and then topping off the coolant level. So this right here is kind of a cool tool. You fill your coolant through your radiator, you mount this little funnel, so it's an adapter, so you can mount it to the reservoir, you can mount it to the radiator. So now imagine your radiator's right here. You attach this funnel, so now you can put fluid in here. You start the engine, you allow it to get hot, and then top off the coolant level when it drops. And what's happening is when you open up a cooling system, you drain the coolant, you put it back together, you top it off, there's always going to be air in that system. And until the thermostat opens and it's completing that loop, you can't get all the air out until that thermostat opens. So you start the engine, you let it run until the engine gets hot enough to open the thermostat, and all of a sudden you'll see this coolant level drop. It'll drop down and you got to top it off again. So that's the conventional way, but there is an easier way. A tool called an airlift. Now I probably have been using this tool for about 4 or 5 years, and it is a great tool. The way this works is you hook it up to a shop air hose, you turn it on, and it pulls a vacuum, a really hard vacuum on the whole cooling system. And it's kind of crazy because you'll see the radiator hoses flatten right out. It pulls that much vacuum on the system. You turn that little valve off, you hook the other hose up, which now goes into a bottle of coolant, and you open it, and it backfills the system. By doing it that way, you get about 95% of the air out, and you don't have to wait for the thermostat to open, so it's a good time saver, and it's a pretty cool tool. So okay, now we're going to hop into the HVAC system. And again, HVAC refers to heating, ventilation, and cooling. The HVAC unit that you'll see here, which typically sits under the dash, but deflects airflow through it. It deflects airflow through either heating or cooling elements. It also diverts the air through different vents, meaning your defrost, your dash vents, or your floor vents. This HVAC unit is located under the dash, and sad to say, but these things are horrible to service because guess what? You got to remove the dash on, as far as I know, every vehicle except for some really older vehicles. You got to remove the dash just to access this, and then you still have to separate it from the firewall, take the heater box out, and then you can split it open to replace heater cores or the AC evaporator. And we're going to talk a little bit more about that, but that is what you need to know. Okay, so exploring the HVAC unit. Let's take a look in this thing. The HVAC unit houses these two cores. Now they look just like radiators because they work just about the same way as a radiator. They're heat exchangers. But this is going to be your heater core right here, and this one over here is going to be your AC evaporator core. There's also what we call blend doors and mode doors. These control airflow. So now the door that controls the temperature refers to the blend door. We call that the blend door. The door that controls or diverts the air into different vents, we call that the mode door. Most HVAC units or vehicles use electric servo motors to open and close the vents, or open or close the blend door and mode door operation. Some vehicles use cables, some vehicles use vacuum, most of them are electrically controlled. And the blend doors and mode doors are controlled by the HVAC module located in the dash. This is an example of an HVAC module, also known as the head unit. But whenever you have an electronic servo, it's going to be controlled by that bad boy right there. Okay, let's look at the heating system. So if you don't live in a northern state, I hope you appreciate that. It's not much fun, and you need heat if you do. So heating system is pretty simple. Hot coolant flows through the heater core and gets blown past the heater core and through the vents. So hot coolant's going through the heater core. You turn your blower fan on, it blows air through the heater core and heats it up and comes out the vent. So it's pretty simple. When the defrost is turned on, the AC compressor will also turn on. That's something that, unless it's really cold out, something that's a lot of people don't know. You turn your defrost on, even with your heat, your AC compressor turns on. The reason it does that is to help dry the air. So most people do not know that. A lot of techs even, they're like, why is this AC compressor on? Well, because you have your defrost on, and it just helps dry out the air to dry off the windshield. So now we're switching gears again, talking about the air conditioning system. AC systems are a little more complicated. Here's how they work though. Here's the trick to them. They work by changing refrigerant, which is the R134. They're also coming out with a new one right now, but it changes the refrigerant from a liquid form into a gas form and back again. That's the secret behind the air conditioning system. So let's take a look at the different parts of an AC system. Let's split the system into two sections, a high side and a low side. So our air compressor, AC compressor, begins the cycle. Freon exits the compressor as a gas form, and it's going to go through the AC condenser right here. It comes up to the right here, the AC orifice tube, also known as, some use an expansion valve. It's the same part. We're going to talk about that later. Right there, the pressure changes and it turns into a liquid form. The orifice tube is basically a small diameter hole, so high pressure is coming to there. It's getting blocked right there. It's such a small hole that as it trickles through there, now it's lower pressure, it turns back into a liquid form. And a good way to remember this is the condenser equals hot, the evaporator equals cold. So let's take a closer look at some of these items. The AC compressor. So the compressor has a suction and a pressure port. There's two ports on there, a suction and a pressure inlet. It's commanded on using a magnetic clutch. So this right here on a normally off compressor, so if your engine's running, your compressor's off, this pulley is spinning. This center piece right here is not moving. So this is an idler pulley. It spins without turning the compressor. As soon as it's commanded on, there's a magnetic clutch that now activates, and now it spins the center here. So now your compressor is actually spinning. Compressors take a special kind of oil called PEG oil, and your shop's probably going to have lots of that. Compressors require a special type of oil, a PEG oil, to keep them lubricated. We're also going to look at a condenser right here. So the condenser is always in front of the radiator. It sits right next to the radiator up front in the vehicle. It requires the use of a fan to cool it. Also, these things are very easily damaged, so be careful. Sometimes it's, if you need to work up there, sometimes it's best to take them out so you don't wreck them. But be careful with them. Okay, orifice tube and expansion valves. You saw that in the system as the pressure went through there and changed from its gas to liquid form. That's really what this thing's job is. So both of these parts accomplish the same thing. It restricts the flow of liquid to reduce the pressure after the tube or valve. This helps to allow the gas to turn back into a liquid form. And again, turning the refrigerant from a gas to a liquid form is really what changes or what creates a cooling effect. Either one of these parts should always be replaced with a compressor failure. Reason being is they can collect debris and get plugged up. So just if you have a compressor failed, just replace these no matter what. Evaporator core basically works the same as a heater core, only it gets cooled instead. So this is where the liquid refrigerant changes form and becomes a vapor or a gas. A orifice tube's going to be located just in front of this. So yeah, it turns back to a liquid form and fills this evaporator core up, and sometimes these things get so cold that they actually start to ice up. Accumulator dryer. This is basically a filter. It works as a filter to filter out both debris in the system and moisture. Again, if you have a failed compressor, you definitely want to replace this part because it's definitely going to have some metal or some debris in it if you have a failed compressor. AC refrigerant. The most common one is R134. Most shops use a machine which is going to evacuate this system or pull vacuum, evacuate. You can recycle refrigerant. So if you have a system that you need to work on, you need to remove the refrigerant out of it first before you open it up. That's what an AC machine will do. It recycles the refrigerant. It'll pull vacuum and can also charge the system. I say pull vacuum because once you've done anything to an AC system, you put it back together. You need to pull vacuum to remove the oxygen out of the system because oxygen equals moisture. We want to get the moisture out of the system. Some air conditioning tips for you. We use these gauges right here to watch the pressure. We always want to keep a close eye on the pressure when we're doing something to the AC system. Watching the pressure is the best way to evaluate an AC system. A normally functioning AC system, you'd see your pressures right around 29 and 215. The blue gauge right here is our low side, so you're going to see that somewhere around 29, and this red gauge right here is the high side. Normally functioning AC system, we're going to see that right around 215 psi. There's always going to be a sticker underneath your hood of the vehicle you're working on, giving you an indication of how much refrigerant is required for that vehicle. So you're going to see a sticker under there. Usually it's yellow, sometimes it's white, and it's going to say on there refrigerant, and it's going to say 1.6 pounds, or sometimes it's going to say like 25 ounces. And anyways, that's how much refrigerant that vehicle is required to take. Another thing is, for a good functioning air conditioning system, we want to see a 20-degree difference between atmospheric air, or the air outside, and the air coming out of the vents. So a good one, we want to see 20 degrees. I like to do that with either an infrared temp gun, or they make just a little, almost looks like a baking thermometer. You can stick that in the dash and get a good reading. So if it's 80 degrees outside, we want to get 60-degree air coming out of the vents. If it's 90 degrees outside, we want to get 70-degree air coming out of the vents. So sometimes it's more than that, but that's the minimum that we want to see. So there you have it. That is it for Module 5. So we know all about engine cooling and HVAC systems now. Module 6, we are going to talk about transmissions and final drive systems. So the drive line of the vehicle. So we will tackle that next, and thanks for watching.